This is my final functionality demonstration on our final project, which is the digital alarm clock. So as a demonstration, let me show you my project. So this part here is the base clock itself. So as you can see, the blue blinking light um, indicates the frequency of the clock. So if I turn this potentiometer, it would speed it up, and if I turn this down at around 721 ohms, which is around here, that would compute to exactly 1 hertz, and or approximately 1 hertz. And in order to, for example, the current time is 10:17. So as seen in this breadboard, it states 11:25. So let me just adjust that. So this button here is the button to adjust for the hour, and this is the button to adjust for the minute. So like so. So if this once it reaches 59, it would just count back to 0. So 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 17, up to 17. So that's 17, and here we need to adjust it to 10. 5, 7, 8. So that's 10. So if we want to set an alarm clock, so it's 6:18 now. So that's 10:18. And if we want to adjust the alarm clock, instead of using counters, because some of my decade counters broke, so I do not have enough counters to complete the circuit. Instead of that, I use dip switch. So it would be binary, through binary. So for example, it's 10:19 now, and my alarm is set to 10:19. So there, that's one. And then flip binary 1 and 4 here to 19. So that's 10. So that's already 10. And then here there's 1 and then 19. So if this clock matches this one, the sound here in the buzzer will sound up. So let me reset that to get rid of the annoyance. So basically, the parts I have here is this part of the circuit is the one that's responsible for counting 60 seconds. And then after 60 seconds has passed, it will send a signal to this part of the circuit. So this part of the circuit is for the minute, and after 60 minutes, it would send a signal here, which is the hour counter. So these are the counters here in the lower part. In the upper part, we have the 7-segment display decoders, and in the upper part of that is the 7-segment displays. So we have in the alarm module or alarm circuit, as you can see, we have these binary inputs, which are the dip switch, and then beside them are the displays, which decodes it into these 7-segment displays. So what I have in the lower part here is the comparator circuit. So these 4 chips are XNOR gates, which means that if the input here and in this clock are the same, it would send a signal to these chains of AND gates, which is I have done in order to have these 16 different signals um, to output one signal, which is transferred here in this clock here, that would send a signal to this buzzer, which would sound whenever the time here and the set alarm here would match. So basically, that's my whole circuit. So these wires crossing each other on these two breadboards are the ones responsible for sending the signals from the clock to this comparator circuit.